This presentation is for the Globalization Symposium in the 2022 IEEE IPC conference in Vancouver, British Columbia, Canada. My name is James Zhou, and my co-author is Weibiao Chen. We, on behalf of Shanghai Institute of Optics and Fine Mechanics, Chinese Academy of Science, and the School of Electronics, Peking University, present the title of this presentation, Photonics in a Time of Rapid Growth, Silicon-Based Optoelectronics in China. Our presentation will be divided into three parts. 1, introduction. 2, academic research in China. 3, industrial development in China. So, what is the silicon-based optoelectronics? SBO in short. Silicon-based optoelectronics is to explore the novel principles of micro-nano scale photonic, electronic, and optoelectronic devices in different material systems and use technologies and methods compatible with silicon IC process to heterogeneously integrate them on the same silicon substrate. It is a science and technology to form a complete and new large-scale optoelectronics integrated chip with comprehensive functions. So my personally involved many earlier on silicon-based optoelectronics in China. In 2003, government approval of Wuhan National Laboratory for Optoelectronics in Wuhan. 2005, I established dedicated research group, Silicon Photonics and Microsystems in Zhou University of Science and Technology, and held the largest, most influential Optical Valley of China International Symposium on Optoelectronics. 2006, I conducted a 973 project. It's called Fundamental Research on Novel Silicon-Based Micro-Nano Optoelectronic Devices and Integration Technology for Zhou University of Science and Technology. In 2009, I edited a focus issue on silicon photonics and published in Chinese Optics Letters. In 2010, the first international workshop on frontiers in silicon photonics was held in Beijing. 2011, the Summer School on Silicon-Based Optoelectronic Technology and Applications was held in Beijing, and it's been conducted annually until this year. 2011, A63 project was kicked off, dedicated on silicon-based optoelectronics. The name is Silicon on-Chip 100 gigabits per second coherent transceiver technology, which was conducted by PKU. In 2012, I edited a dedicated book, Silicon-Based Optoelectronics, which was published by PKU Press. So the status on silicon-based optoelectronics in China right now can be summarized as following. China actually started the silicon photonics research earlier in this century. Many universities and research institutes have been engaged and produced world-class results and publications. A few pilot lines are up and running. More advanced production lines are in progress. handful of startups have been established, and some large-scale companies are also seriously planning for this potentially very large market of silicon-based optoelectronics. Many local and central governments become the strong supporter for this silicon-based optoelectronics. Now, let me move into the second part, what's happening in academic research area in China. Many Chinese university and research institute has been engaged silicon-based optoelectronic researchers. And here I only list a few. The university include Peking University, Zhejiang University, Shanghai Jiaotong University, and Huadong University of Science and Technology. The research institutes are all come from Chinese Academy of Science. They are Shanghai Institute of Optics and Fine Mechanics, Institute of Semiconductors, Institute of Physics, and Shanghai Institute for Microsystem and Information Technology. Let me give you more details. In Peking University, we focused on silicon-based optoelectronic computing, basically try to do computing on silicon-based optoelectronic chip. We do not call it silicon, we do not call it photonic computing. We do not call it optical computing. We only recognize that opticals are very useful for optical bus, some of the matrix computing, and also some OI parts. Rest of those have to be rely on microelectronics. That is say, is silicon-based optoelectronics technology can be used to accelerate microelectronic-based computing in a big way, but you cannot call optical computing. In SILM, research actually produced a hybrid integrated self-injection locking nano line-width laser based on feedback tunable silicon nitride microring resonators. So the line width actually been narrowed from 130 kilohertz to 47 hertz. In semiconductor, instead of semiconductor, the high-speed germanium tin on silicon photodetector at 2 micrometers has been developed. So the speed can go, the 3 dB bandwidth can be greater than 30 gigahertz at 2 micron at -3 volts. The Shanghai Jiaotong University developed a silicon photonic integrated direct detection receiver with the highest electronical spectral efficiency. The efficiency can be as large as 4.6 compared to rest of them are basically all below 4. Shanghai Jiaotong University also developed a fully integrated solid-state LiDAR transmitters. And the Huadong University of Science and Technology developed an 80 gigahertz germanium wave-guided photodiode enabled by parasitical parameter engineering, and the bandwidth improved from 27 to 80 gigahertz. Zhejiang University developed a new NIR emitters based on urban hyper-doped silicon quantum dots. It also developed high-efficiency open grating couplers. The loss can be as low as 1.56 dB. Institute of Physics basically embedded the growth of indium arsenide quantum dots laser on silicon on insulated substrate with direct edge coupling to silicon waveguide. The coupling loss actually less than 7.6 dB. So let me move to the third part, industrial development in China. Two parts. One is pilot lines, two is corporations. There's three important, the most mature silicon-based optoelectronics fabrication pilot lines. The first one, the most mature one, can be the CUMAC. That means Chongqing United Microelectronics Corporation. It is an 8-inch pilot line, and they can be used for 3D packaging, can be used for low loss silicon nitride, waveguide, passive devices, and the most important, they can run the 130 nanometer copper-based silicon photonic chips, and also 180 nanometer aluminum based, using aluminum as the interconnection for silicon photonics. And the second pilot line is called the C-chip, 180 or 90 8-inch platform. C-chip is the Shanghai Institute for Microtechnology Research and Institute. That's basically standard conventional silicon-based optoelectronic process line using 220 nanometer thick silicon. They also use thick SOI up to 3 micron to develop a more variety of silicon-based optoelectronics chip. The third pilot line is from the Institute of Microelectronics of Chinese Academy of Science. They can continuously run the MPW for research and for small business now. Now, in terms of a cooperation, because Chinese industry or microelectronic industry is actually behind the rest of the world. So those kind of company, silicon-based optoelectronics companies is developed a little bit slower. This picture shows the silicon-based optoelectronic industry chain that include the EPDA, SOA wafer, and the epitaxing, and the design, foundries, and the system applications. Those actually list the companies from the world. The red dashed line square indicating the Chinese companies, like this Latitude Automation Design for design, and this Singui for wafer, and also we have this QXP for design, and the foundries. We have CUMAC, as I mentioned there, and of course end users, including Huawei and ZTE, and many other data center or mobile companies. So from these pictures, you will see the fabrication company, the commercial company is kind of behind, but design is kind of coming up, and the academic research is actually kind of similar, as a little bit behind the rest of the world. Yeah, that's the SBO industry, the status. Now, let me take rest of the maybe a couple minutes to introduce the SIOM, the Shanghai Institute of Optics and Fine Mechanics, Chinese Academy of Science. It was established in 1964, and It is located in Zhiping district of Shanghai. They have 7 campuses scattered into China, and one of the earliest. It is one of the earliest institutes specializing laser science and technology in China. But right now, it is specialized in laser and optoelectronics, including high power lasers, high field laser, physical space laser, and time frequency technology, and so on. And the most important is they are really interested in laboratory or space laser engineering and the technology. Try to use the silicon-based optoelectronics for laser communications in space. And most important, last but not the least, is this SIOM. It has a published house called the Chinese Laser Press. Inside this Chinese Laser Press, they are publishing 7 English version of journals. As you may know, the photonic research is well known by the world. And humbly and honorably, I am the founding editor-in-chief for this journal. And it's been very well known in the world now. So with all this, I thank you very much for this talk. Hope if you have any questions, I can find a way to answer you.